Alright, so that's one of the applications of that idea of volume being a product. Now let's go back to that formula. That volume on three vectors u, v, and w is equal to the dot product. Okay, dot product of u and a vector, some vector. Let me call it xi. In the file I call it xi. And xi is that sort of complicated vector made out of coordinates of v and w. So there is 2 by 2 determinant as a first coordinate, negative 2 by 2 determinant as the second, positive 2 by 2 determinant as the third, and v's and w's show up in those determinants somehow. So I'm not interested now in details of how those determinants are written. I will look at this equation and I'm going to play with it to figure out the properties of xi. And again, you see, it's going to be a play when I don't use explicit formula for xi. It's again going to be a discussion at the level higher than coordinate level. Right? We go more abstractly, we forget about details of how things are built, and we care only about the properties. So let's figure out properties of xi. The first observation is that if you look at this equation, it holds for all, well, for any three vectors. Any vectors you choose, u, v, and w, that equation holds. That's just a matter of computation that is already done. And now you want to figure out something about xi, and xi shows up only once. So what I can do is I can play with this u. And the first thing I do is I replace u in this equation with v. And I will rewrite the equation again. Instead of u, I put v. And my equation becomes v dot xi. What's good about it? Come on, wake up. Anytime I ask you what's good about it, the answer is something is zero, right? Now, do you see what is zero? Well, the volume is zero, right? V, V, and W. Now, what's the meaning of that? Well, we just figured out the meaning of volume being zero. But what's the meaning of dot product? V. It means V is perpendicular to xi. Right? So that's it. I conclude that xi is perpendicular to V. Well, you see, xi, remember, it's made of V and W. And it happens to be perpendicular to V. Now, is it perpendicular to W? Why don't we do the same thing? I will use the same formula, but instead of U, I will use W. W, V, W equals W dot xi. Left hand side is 0. Dot product being 0 means they're perpendicular. So xi is perpendicular to W. How much do I know now about xi? So remember, I had a vector v in 3 space, a vector w in 3 space, and now I figured out that vector xi is perpendicular to both. Does it determine the direction of xi? Does it tell you something about how it's directed? if you have two vectors in free space, and a third vector should be perpendicular to both vectors. Doesn't mean that you have this plane determined by v and w, and the vector xi should be somehow perpendicular to the whole plane. So that basically determines the direction of xi almost uniquely. If you have a plane, there is only one way to be perpendicular to it. One way or the opposite way. Right? So these two simple things tell you how xi is directed. So it is directed along that line perpendicular to the whole plane.